So welcome. I'm so excited to see people this morning and to have people joining us for the conference. I'm Karen Reinhardt, and I'm an ALN presenter, facilitator, I should say, a little bit more of a presenter today. And I also work for the ongoing assessment project and have been a math coach, and also work right now for the University of Michigan for an organization called Teaching Works. And one of our main focus at Teaching Works is to support all learners, and in particular to disrupt injustices for marginalized communities. So that work is near and dear to my heart right now. And so I feel like All Learners is really committed to those ideas as well. Okay, if you would join me on slide 4. These are a set of rights that I learned from my colleagues at the University of Michigan. Every summer, we do a professional development opportunity called the Elementary Mathematics Laboratory, where we work with rising 5th graders. And the teachers teach the students in the morning, and then they have different activities in the afternoon, and we have various professional development offerings in the afternoon. And the teachers this year shared these rights with the students. And so ever since I saw these, I have shared them with every group that I've worked with because they feel really important to me. So take a minute and read these rights. And these are your rights today as a learner. Some school groups I've worked with have also shared these rights with students. And if we had more time, we'd have a conversation about it. But one of the things that feels important to me is I think not all students come to school believing this. I'm not sure every student believes that they have these rights. And so it feels really important to me to share those with kids and to help them really feel included and supported at school. And again, with adults. So just sharing them with you today. All right, so today we are going to talk about specific strategies for supporting all learners to participate in discussions. And a lot of these ideas will echo the things that Bob said this morning. So wonderful to hear Bob and be inspired by him again. So that's one thing to be thinking about today as we're working together is sort of how some of the ideas here echo what Bob said. So we're going to do a short activity together. I'm going to put you in breakout rooms really quickly, and then we'll share ideas. We'll have a short discussion about them about the mathematics, and then I'll show you some videos of some of the ideas in action. So if you would join me on slide 5. So we're on slide 5, and this is a problem that we're going to do together, and I'm going to send you into breakout rooms in just a couple of minutes to work on this with a partner, okay? So I'm going to share this problem with you. I'm going to put the slides in the chat. Slides are in the chat. We're going to use a process for unpacking problems that members of the All Learners Network created. And there's information about this on the All Learners Network website in the blog. So if you're looking for a copy of this protocol and sort of ideas about how to use it, it's in there. But we're going to talk about this problem together. So the first part of the All Learners Problem Introduction Protocol is to read the problem together chorally. Okay, so we're going to read it. You can have your microphone on if you want, but this is the way I would do this with students. Okay, so arrange the light green, red, and purple rods in a row using exactly one of each rod. Find all the possible ways to put 3 rods in a row. Prove that you have found all of the different ways. Okay. So the question here is, as learners, what are we trying to figure out? And you are welcome to share that out loud with the group, or you could type something in the chat. Okay, I see all the different ways to arrange the rods. Different combinations. What are some of the conditions around using the rods? Like, what are some of the rules of the problem that you see in the problem? They have to be in a row, yeah. And so for our purposes, that means like in a line, okay? This problem is called the 3-car train problem. So you can kind of think of those as rods in a row. And if we were together, we would have Cuisenaire rods to do this. So you can imagine putting the 3 Cuisenaire rods in a row. Yes, we need to use only one rod, each rod one time in a row. And we have to prove that we found all the ways. Okay, so what might an answer look like? Like in a few minutes, you're gonna work with a partner and you're gonna put your answer on a slide. So what might you see on people's slides? So drawings, representations, a table, a model, color words. Great ideas in the chat. Okay, what would a wrong answer be? Given our conditions and given what the problem is asking us, what would a wrong answer be? Okay, only one way. 2 rods of the same color in a row. Yep.
Or possibly just only 2 rods, not 3.
Not 3 rods, yep. Because you have to use 3 rods. Okay, and I think we actually answered to some degree some of the strategies. So people said a table, people said representations. Anybody else have a strategy that they're thinking about in terms of solving this problem? Color words. Okay, put your thumb up if you feel like you have a way to start. Great, and for those of you who have your camera off, you can use the reactions button at the bottom of the Zoom screen also. Okay, looks like people have a way to start. So I'm gonna give you 2 minutes to work on your own, to have quiet think time. And then I'll send you into breakout rooms with a partner. So I'm gonna start my timer right now for 2 minutes. So this is quiet think time. So that was 2 minutes. It's okay if you're not finished because you're going to have a chance to talk with a partner in a breakout room. So again, I'm going to send you to a breakout room. Actually, join me on slide 6. The directions are in there. So with your partner, you're going to have like 7 or 8 minutes. Briefly introduce yourself and then share your strategies for solving this problem. Please then go to the slide that is representative of your breakout room. So there's breakout room 1, 2, 3, 4, and so forth. So go to that slide and share your strategy. You could take a photo of your work, you could type on the slide, however you want to do it, doesn't matter. Okay, and remember, you need to prove that you have them all. Any questions about the job? Okay, I'm going to send you into breakout rooms. It's going to come up on the screen that it says you're being invited to a particular breakout room. And I'm just going to pop in and listen, so you don't need to talk to me when I come in. I'm just going to be listening in. Okay, off you go. Welcome back, everyone. Thank you so much for navigating that quick breakout room time. And I know for some folks, putting strategies on a Zoom slide might have been a new thing. So thanks for navigating all of that. What I'd like to do now is just take a couple of minutes and have you look at maybe 2 other group slides if you haven't done that already. And what I'd like you to think about are two questions, and the questions are on slide 17 if you'd like to see them. So what differences do you see across the strategies and the representations? And then is there something on another group slide that struck you and like helped you see the solution? Okay, so like something you might have learned or seen in another group slide that you might want to try next time. Okay, so differences and something that struck you, right? So just take like a minute and look across, look at two other group solutions. Either share out loud with the group or write in the chat. What are some differences you noticed across the strategies?
Just some are much more visual and some are more within the realm of like calculation and number.
Okay. So people are representing in different ways. We have rods, we have cubes, we have colors, pictures of rods, and other people are using letters or lists. Yeah. Are there any, did anyone see something on another slide that struck them like that they might want to try? And again, some people are sharing in the chat, so you want to be looking at the chat. Yes, that is 3 factorial. Yeah, we went from visuals to tables to algebraic proofs to written response. Okay,
sorry.
Go ahead, team. No,
I was just going to say, I really liked the slide that had the emphasis on concrete to representational to abstract, the CRA response. I liked a lot.
So slide 14.
Like everyone's.
Mm-hmm. All right, I'm going to keep us moving just because we have a short period of time. If you would join me on slide 18, what I'd like you to do is take a minute and think about how it felt to be a learner in this problem. And we're not going to share that out. But what I do want to share out and create on this table is what about the task gave you the opportunity to participate? And what about the facilitation, like the way the task was structured, gave you the opportunity? And again, you can speak out loud or you can type those things in the chat. So let's take a minute of quiet think time. This is what Bob was talking about this morning about opportunity, right? We're talking about opportunity to learn and access to the mathematics. So that's what we're talking about. What about the task? What about the facilitation? Go ahead and type in the chat what ideas you have. And I'm summarizing on the slide 18. There isn't really any magic about that problem introduction protocol. It's just again, sort of a series of steps that people in the network agreed upon, and talked a lot about and thought a lot about. But I think using it is the critical thing. Using some strategy for unpacking a problem that allows kids to make sense, as opposed to like reading them the directions and walking them through. So I've seen lots of teachers with wonderful intentions trying to support all students to join, and it ends up being like me telling you what to do and it being a following directions kind of task. So the importance of asking those questions. Okay, so I'm going to shift us a little bit. That was sort of a grounding experience that we had together. And I'm going to shift us a little bit to thinking about this idea of status and recognizing competence, which is where some really specific discussion strategies will come in. So someone asked, what's the intent of choral reading? It is to give access to anybody who is not a reader, and to really cue kids into those different pieces of the problem. So the teachers in the All Learners Network actually had a long conversation about like whether this was appropriate for older kids, and older kids like might sigh or sort of roll their eyes or whatever, but we've agreed that we feel that it's really important, particularly if you have language learners in your classroom. Reading the problem together allows everybody to have access to the words. Okay, if you would join me on slide 19. And this is a long quote, but I think it's important. So take a minute. This comes from the book Smarter Together, which is one of my Bibles around supporting kids to participate in math class, and the reference is down at the bottom of the slide. So take a minute and read this. And what I'd like you to do is think about a student that, well, read this for a minute. Okay, so I think one of the critical elements of having all students participating in discussions is around this issue of status. So students have status in our classrooms based on all kinds of things, as this quote suggests. And one of the things we need to try and do as mathematics educators is disrupt some of that so that all students feel like they sort of have the right to participate in class. So I know lots and lots of kids. I've had kindergartners tell me they're not good at math. And if I feel like I'm not good at math in the classroom, I'm probably not going to be brave enough to participate in a discussion. So one of the things we can do as teachers is intentionally disrupt this idea of not good at math for our students who maybe, and particularly kids in older grades, may have had this idea for years and years and years. So I'm not saying this is an easy thing to do, but I think it's an important thing to consider when we're trying to have all students participating. If you would join me on slide 20. So what can we do? One of the really concrete things we can do is intentionally assign or recognize competence in students. So the language in the Smarter Together book, they use the word assign, but my colleagues at Michigan and I are thinking that that feels like it's the teacher giving the competence to the kids, when really what we're trying to do is find the competence that already exists in the student. So we try to use the word recognize or highlight or bring to light the competence that's already there. So as teachers, we have huge power, right? And so we want to use that power to highlight students, and particularly students who have low competence in our classroom. So one of the things we need to do is we need to broaden and label what being competent in mathematics means. So this gets, ties exactly to what Bob was saying this morning. So many of our students, and again, even young students, think that math is calculation. If you ask many adults what it means to be good at math, they'll say it's to get the right answer and to get it fast. So if that's what our kids think mathematics is, and that's the mathematics that we're teaching, that's a very narrow slice for kids to be able to show competence. I was talking to a teacher the other day who was very successful in mathematics and still, through college, and still feels bad that he still doesn't have his math facts, right? So we have to broaden what we see and label and highlight in our classrooms as mathematics. So more children with more skills have the ability to participate and the opportunity to participate. As I said, then we need to intervene and reposition students so that they are seen as competent rather than not. And along with that, supporting children, individual children, to develop their academic identities and competencies. Any questions or thoughts about that? And again, I would invite you, as Bob did, to have this student in mind, or a number of students in mind who felt they had low status in the classroom, in particular around mathematics. And again, it's not to say that any of us are intentionally putting students in those positions. Of course we're not. But there are things about our systems, in particular the use of high and low, those words, like we have our high kids and our low kids. And whether you call them bluebirds and robins or whatever, the low kids know who they are. And oftentimes that becomes a self-fulfilling prophecy. So again, we need to watch our language, as Bob said, and our labels, and intentionally disrupt kids who feel like they have those labels or feel like they have low status. Okay, if you would join me on slide 21. So again, this is kind of a different way of saying what we've talked about. So we need to be able to see what's mathematical and what is competent. So we need to change our lens so that we're not just looking for right and wrong answers. And those 3 pieces of student work, it was so great that Bob went before me. Those 3 pieces of student work that he showed were a great example. If we had only been looking for right and wrong, the student who had the most sophisticated strategy would have been termed wrong and the other 2 would have been termed right. And that wouldn't have given us any information about where to go next instructionally. So we've got to know the math well enough so that we can see the good work that's going on and the strategies that students have. We also need to intervene at times to be able to highlight when a student is showing their competence. And we need to highlight that to the class so the rest of the kids are seeing that student as competent. That's the only way we're going to disrupt these labels and these status issues. Any questions about this? Okay, let's see it in action. All right, so we're going to watch 2 video clips. I'm going to share my screen. So we'll make sure it works. I'm pretty sure you'll be able to hear. And what I would like you to do is I'd like you to jot down some notes because we are going to report out. Based on what the teacher does and says, what are the different ways that she believes students can be competent in math? So this is this idea of broadening mathematics, like write down what she sees as being competent in math, okay? So that's number 1. Number 2 is what specific techniques does the teacher use to position the student as smart? And you'll probably see more of that in the second clip. Questions about what we're thinking about? So I'm going to share my screen. So if you still have your slides open, you can see those 2 things. So what does the teacher believe competence in math looks like, and what techniques does she use? Okay, I'm going to share my screen.
What happened?
Here.
Which problem? Oh, why are you going back to it right now, though?
Because
I'm sorry, Maya. What does it ask you about that one? I'm sorry. Okay, so you don't have to finish it to be able to solve this one. Are you feeling frustrated with this problem? Do you know what was frustrating you about it? Where is it? What was frustrating, Maya?
I can't explain.
What do you know? What? Let's just talk about it for a minute. You don't have to do it right now. We'll have more time. But do you know what was getting you stuck?
Explaining it is, I got mixed up with the answers.
Do you want a clean sheet tomorrow? Okay, but do you know when you read this, there's something you don't understand about the story?
I understand the story, I just don't know how to explain it.
Okay, so how much can he buy at the store? You can buy gum or chocolate kisses. And how much does the gum cost?
3 cents.
And the chocolate kisses?
4 cents.
Okay, and how much can he buy of each one?
3.
Right. So the most he could get would be 3 what? 3 kisses and
3 sticks of gum.
right. Could he buy less than that if he wants to?
Yes.
Right, but he couldn't buy like 6 gums, right? Does that make sense so far?
Yeah.
Okay, so just before you go, tell me what's the smallest amount of money he could spend then if he followed those rules?
3 cents.
And how would he spend 3 cents?
Buy 1 stick of gum.
Okay. Does that make sense? So tomorrow when we have some more time, let's make sure that you feel like you get what's going on, because I know you can do it. Were you frustrated during warm-up today too? But you didn't want to tell me at that time? So then when it was on the end of class check, that was more frustrating, or what happened? Okay. So why don't you write something here that says, this was a frustrating problem today? And do you think that if we get you set up tomorrow, it's something you can persevere with if you make sure you understand what's happening? Yeah, I think you can. Next time, don't get yourself to a point where you feel this upset without telling me, okay? That's not my goal. My goal isn't for you to be crying in math class. I want you to feel like you can do the work. and if it feels too hard, you know what that probably means. It probably means we need to talk a little bit and make sure I get you off and running again. Does that make sense? Is there anything else you want to do about it today, or you feel like if you came back to it tomorrow, it would be okay?
Okay, that's it tomorrow.
Here's a tissue.
So take a minute and think about what is this teacher communicating that she values about mathematics, or what does being competent in mathematics mean? You can just write an idea in the chat when you're ready. So I see sense making, understanding the problem, every student can do the math. What about dispositions? So I see a lot of people sort of connecting with how the teacher is treating Miah as a human being, as a person. What is she not doing with Miah? What doesn't she do? Yeah, she doesn't give up on her. She doesn't tell her what to do. So many of us, in our attempts to be caring and respectful of students, let students off the hook. Say, oh, this is too hard. That's okay. You don't have to do it. The teacher doesn't do that, as you're all saying. She's asking her guiding questions. She's showing her what she knows. She's sticking with her, and she's letting her know she's going to come back to it tomorrow. So I think a lot of times, out of our kindness and out of our maybe discomfort when students are upset, we let students off the hook, which I think gives them the opposite message that we intend. It says, I don't think you can do it, so I'm going to let you not do it. And that's not what we're intending, I don't think, but I think that could be the message that students give. We did, some of us in an all learners cohort, which some of you are a part of, asked students who had been pulled out for math class how they felt about being pulled out, because we were concerned that it had an effect on how they saw themselves as math learners. And interestingly, although, well, I won't judge it, the students said they really liked being pulled out. They liked being with their peers. They liked having a teacher who was, interested and excited about the work they were doing together. They felt that more in the small group. But when we asked them how they felt about themselves as math learners, they almost to a kid said they weren't good at math. So it's important, I think, to think about how kids are viewing themselves and how some of the actions, again, as Bob said this morning, some of those things that winnow the opportunities for kids, and letting them off the hook or giving them unchallenging math is one of the ways that we're winnowing their opportunity. Okay, so again, great ideas in the chat, so be sure you're checking the chat. We're gonna watch another clip and we're gonna see what happened. So this was at the end of math class for the day, again, in the elementary math lab. So this next clip is the following morning. So you're gonna see Deborah Ball, the teacher, greeting Miah as she comes into class. And then you're gonna see her circulating as Miah is working on a problem. And the problem she's working on is the 3-car train problem that you did, okay? So what I'd really like you focusing on this one is, again, what does the teacher value as being competent in mathematics? And specifically, what techniques does she use to highlight Miah's competence? Okay. And I'm just going to go to the part in the video where the new section starts. So it'll just take me a second to do that.
What happened? I feel like you can just to try hard and think hard, but not.
Okay.
So read your notebook where you wrote the note to yourself.
Oops, I got to back up. There we go.
Miah, how are you this morning? Better? Next time, remember that if you ever feel like that, talk to me. Don't let it go all morning. I also read your notebook where you wrote the note to yourself. I like the part where you wrote P.S. Of course you know, because I read it to myself. So even when you were feeling frustrated, you had a good sense of humor. Have a good morning. How are you? Miah, how's it going today?
Good, but I don't know how to explain it.
You're not done yet?
No, I don't know how to explain it though.
Okay, we'll just finish writing out what all of them are. Okay, so who thinks you could go to the board and try to explain? Actually, before we do that, why don't you turn to your partner and see if you can try out your explanation on your partner and see if your partner thinks that would convince somebody. Try out how you would prove it to your partner.
No seven
What would you
pattern
say?
to do. We followed all the.
Look up. Who would like to try explaining on the board a way that would prove that our class actually found all of them? Miah, would you like to try? Okay. Please put your eyes on Miah and see if you think this is convincing.
I know because you can. I drew the first part, the first colors at first, and then I just mixed the bottom, these two, and you know, because you don't worry about these, you worry about if you're gonna how you're supposed to change them. So I put the yellow and green first, then I switched them for green and yellow. Then I did green, and I switched.
I like the way people are trying to watch what Miah's doing. Eyes up on the board.
And then I did yellow, and I only switched these two. And there was no more other colors. If there was, I probably could.
Okay, so now you built your explanation and you were talking at the same time. It was great. Now I want you to try to, since you don't have to build it this time, could you try one more time where everyone can see it and we can see your face too? So everyone look up at Miah and look at her blocks on the board. No one should be looking at your notebook right now.
You have purple with yellow and green. You mix these two parts, and you don't worry about the first one. Then you do the same thing with the other colors. You just change the two other colors in the back.
Okay, if you think that you can explain what Miah just showed, raise your hand. Who thinks that you understand what Miah just showed the class and can explain it yourself? Who would like to try that? Deirdre, would you like to try that? Could you stand up, please? Try, say it from there. Miah, listen and see if she has it right.
Say it from here?
Yeah.
Go ahead.
I think that Miah said that she switched the two colors. She kept the purple, and then she switched the two colors around when it was yellow and then green. She said that she switched them and made it green and then yellow, and then the same thing with the other two colors, and she switched them around.
Is that what you said? Okay, one more person who thinks that was good, Deirdre. One more person who thinks you can explain what Miah showed. Who else thinks you can explain it in your own words? Michio, do you want to try? Stand up. Use your big voice.
I kind of need the cubes to explain this, but I guess I could also do it without the cubes. So, you know how, so you have one main cube that you want it to start at the beginning, and have two extra cubes. You can choose whichever way to put it in the order, of whichever way you want it to, but you only have two ways to put it with the extra two, because you're only going to start with one cube at the beginning. So you're going to have it like that, like Miah did at the beginning, where there's a yellow one and then a green one. But then you can't build that one again, so you have to flip-flop them to make another chain. And then she did the same thing, but she started with a different color at the beginning of the chain.
Is that right, Miah?
Okay. So what are some strategies that you saw? Well, first, let's talk about a little bit more about what the teacher is honoring in terms of math competence. What are some things that she values as part of being mathematical? Yeah, I think one of the things we forget about, this is sort of an aha for me in engaging with these clips, is that whole idea of listening. So one super easy strategy for supporting more kids to participate in discussions is to have them revoice what somebody else said. If we're truly going to learn from each other, meaning we're actually going to try and use each other's strategies, then we really have to listen. So if you're asking students to repeat what another student said, any student can do that. And if a student wasn't listening, you can ask, would you like Miah to say it again? And then that student could repeat. So even though that student may not be furthering the strategy, their voice is in the room and they're participating in the math discussion. And that's like a first step to disrupting the idea that maybe that student has low status. So it's also up to you to choose who you want to call on to ask to repeat what another student said. And you can do that intentionally to make sure that all the students in your classroom's voices are in the room.
I think it also, sorry, Karen, I think it also reinforces the idea that like math isn't this like race to get things done and you get the answer and it's done. Like it's really important that kids are able to say like, oh, it was the reasoning that was important. That's why we're spending so much time on that, not just what the answer is at the end.
Yep. So all these things you said, explaining, listening, revoicing, persevering, taking risks, using models. Think about how Miah might have explained had she not had those models up on the board. Having those models available to her, I think really allowed her to access her explanation. What other specific techniques did you see the teacher use to show or highlight Miah's competence? They're sort of woven into the other things you said, but let's get some specific techniques. Yeah, that turn and talk. It's time to rehearse, right? I'm trying to explain my strategy in front of the class, so rehearsing with the peer is huge. What else? Yeah, so she chooses Miah, right? See, that was not, like she didn't ask Miah ahead of time. That was impromptu. So Miah felt confident enough and the teacher called on her, even though she had struggled the day before exactly with this issue. She was struggling to explain. She even said, as the teacher was walking around in the morning, that she was struggling to explain, and the teacher still called on her. That is showing some real belief in students and what they're capable of. Yep, reminders for other students to listen. Repeatedly using Miah's name. Again, think about how that might make some of your students feel if their names are often used maybe like in behavior situations or whatever, but to hear their name in the context of the math class around an explanation could be really powerful. Yeah, and she went back to Miah. Miah, is that right? So the ownership of the math was with Miah. That's critical. I think sometimes as teachers, we repeat what kids say, like it's part of, we're excited about it and it's part of just sort of a, I don't know, a habit that we get into, and I am absolutely in this category. I'm doing it right now a little bit. But sometimes that's like taking the words from the student and putting it on you. And we want to make sure that the ownership for the explanation and for the mathematics stays firmly with the student. So the teacher didn't evaluate at all. Instead, she said, Miah, is that right? Many teachers that I've worked with have used that particular strategy and found it really powerful. Just going back, having students revoice and then going back to the student and saying, is that what you meant or is that what you said? Okay, let's just go to slide 25 and we'll wrap up with the next couple of slides. So you said many of these things, but just take a minute and read this list for specific techniques. Again, slide 25. So one of the simple ways to do this, and again, I'm sure many of you do this already, if not all of you, is when students are sharing their work or when you're putting student work up in front of others, to have the student's name with it. That was one of the reasons I asked you to put your names on your slide so that we can reference, oh, you know, we could go to slide whatever and look at, you know, somebody's important idea. The critical part of that, as you well know, is that we need to do that for every single student. So sometimes when I was teaching and I was having discussions, I would just have a class list and put a check when I had called on a student or had a student explain. So I'm making sure that I am getting every single student's voices in the room. Oftentimes, and I think this is particularly hard online, you know, we have people who speak up and we call on them because, like, thank goodness someone is participating. But, you know, that's either the talkers or the kids who are feeling confident. So we have to be particularly intentional about making sure that kids who are marginalized in any way have their voices in the room too. Okay, if we go to slide 26. Another way is by explicitly assigning roles to kids in groups. And I would, again, refer to the Smarter Together book. They talk a lot about roles and how to have kids really working productively in groups. And again, I know that that's really challenging online, particularly with younger students, and how tricky it is to get to breakout rooms. But another strategy. Okay, if you would join me on slide 27. So again, I feel really strongly that kind of step one to having all students participate is that all students feel like competent and confident mathematicians. And again, we know that kids come to us, whatever their grade level, having beliefs about who they are as a math student. So we need to find that out, and you can do that by surveys or experiences in math or whatever, building relationships with your students. And then we have to intentionally work to disrupt some of those status issues, both with the class and how the class is viewing a student, like the quote we heard about Miguel earlier, and about how students feel about themselves. So when we're recognizing competence, we can change students' views about each other. We can support students who might not participate to participate. And then again, it's up to us to highlight the smartness that we see so that everybody hears that. One thing many teachers who've worked on this have done is talk to their kids about what it means to be smart in math. And if we don't want to use that term, just what it means to be a mathematician. And brainstorm those lists with their kids and add to them throughout the year so that kids are really seeing that it's not just about calculation. It's about listening. Everybody can listen. It's about, you know, explaining somebody else's thinking. It's about asking a good question. How many kids think that you're dumb if you ask a question in math? Right? But your question might help us understand, wow, what a great question that's going to help us further understand. Thank you. Saying that you don't understand. So supporting kids to have, you know, having a list of those things, I think can help you remember what you want to recognize, what competencies you want to recognize, but can also help kids change how they think about what math is. Any questions or comments? These shorter presentations are harder because they're much more about presenting, which is not my favorite thing, and less about facilitating and discussion, but at least we can share these ideas. Okay, if you would join me on slide 28, kind of a summary slide. So the way I think about supporting kids in discussions is twofold. So the first is kids have to have access to the math. If they haven't done the math, there's no possible way they can participate in the discussion. So if all I'm asking to do, and I know none of you do this, but if all I'm asking to do is have kids do 20 problems on a worksheet, I've left half of my class out, right? So we have to have tasks that allow everyone to participate and ways of facilitating those tasks. Then we need to work specifically in the discussion to make sure that everyone has a way to participate. So take a minute and just read these strategies to yourself. Okay, in our last minute, if you would join me on slide 29, I would love for you to write in the chat, and again, this is your opportunity, not a requirement. What's one strategy you want to try to recognize competence or support all students to participate in discussion? So essentially, what's a takeaway for you? And if you would write that in the chat, I'm sure we'll benefit from each other's ideas. So I see that it's 11:30. Thank you so much for joining today. And slide 30 just has all the different ways to connect with the All Learners Network. And I hope you have a great rest of your day. Thank you so much.